Okay, it's time to get a little fancier here. We're going to graph this equation right here. So it has all the transformations possible. So we need to remember what we know about transforming functions. And sinusoids, which cosine is a sinusoid. I know that's weird sounding. We don't say cosinusoid. I don't know why. It's too long, I guess. But we get it. They have their own vocabulary. So this guy, in terms of transforming a function, it's your vertical translation. But it's using the official vocabulary. This is our sinusoidal axis. But it's also just a vertical translation up one. This 2 multiplying on the outside, if you multiply on the outside, that's a vertical dilation, but the official word we want here is amplitude. That 4 is multiplying on the inside. There are like invisible parentheses here, really, so that whole thing is the inside of the function. If you multiply on the inside, it's a horizontal dilation, but this actually leads us to the period. The default period is 2 pi from just looking at y equals cosine x, but the period is 2 pi divided by that number, so 2 pi over 4, which we can reduce that to pi over 2. And then finally, this last bit, when you subtract on the inside, subtracting, it's what makes this guy 0. A pi over 16 makes a 0. So this tells us we go right pi over 16, and that is called the phase displacement. I always forget that though. Okay, so to graph this, I try to make things as easy for myself as I can. So when I'm graphing these things, I tend to draw a lot of stuff on my graph. Like I first draw in a sinusoidal axis. Well, first I look at my available space and go, can I go by ones? And I can. Because if I have a sinusoidal axis at 1, the maximum will be at 3. So I'm going to draw in a horizontal, like dotted line here for my sinusoidal axis. I'm going to also put my vertical scale in. That really should have gone first. And then I'm going to draw another dotted line 2 above that sinusoidal axis. And then 2 below the sinusoidal axis. So I'm kind of building a frame that my graph is going to fit into. And then setting up my horizontal scale, this is the hardest part. The way I usually do this is I go to the 8th box and make that my period. So 2, 4, 6, 8th box period is pi over 2. So then half of that, so the 4th box, half of pi over 2 is pi over 4. Half of that, pi over 8. Half of that, pi over 16. Can you tell why I picked pi over 16 for that phase displacement? I may have done that on purpose. And I'm going to annoy some people. I'm not going to put any more numbers in. Okay, I'm going to draw a vertical line for my phase displacement. So at pi over 16, I have my vertical line. And then since I made the period 8 boxes, I can go 8 boxes to the right, or just going out to the period, and then pi over 16 to the right, I'm going to draw a second vertical line. So I've built this kind of frame. I can use this frame, and basically these same 5 points that I had plotted, I can consider this to be a frame as well. So when I look at that same kind of rectangle and compare it to this other rectangle, it's the same points. So I don't have to think very hard. And I'm a big fan of not thinking too hard when I'm graphing. I know cosine starts at the top of the frame that I've built. If it was sine, we would be starting in the middle. So there's my first point. I know I'm going to end at the top as well, because I end where the same as the start. And then I just know enough about the patterns, because math is always patterns. Halfway across, I'm going to be all the way at the bottom. And then halfway between the first and the middle, I'll be in the middle. And then 3/4 of the way across, I'm back to the middle. And then I can just put more points in if I want. And then I can draw a nice smooth curve. And there's my graph. Just a couple reminders. Say this had been like a -2. The amplitude would still be 2 because an amplitude is a height, but it would just be flipped upside down because it would be that vertical reflection. Not a big deal. So there is graphing a sinusoid with all the bells and whistles.